All right, I know I wasn't there in class to help you guys with reviewing, and I want to make sure you guys get the help that you need as you are preparing for your test on Thursday. So I want you to take a couple minutes if you haven't already, and I want you to use the answer key that I attached to my email and that I posted in Google Classroom, and to check your answers and see how you did on the review. Then when you've done that, I want you to use this video to go to whichever questions you might still have some questions on, or any sections that you had some trouble with. Jump ahead in the video, go watch those particular pieces, and use that to hopefully help answer some of those questions and get you on the right track with how to tackle those problems. So don't feel like you need to watch the whole video. Watch whatever pieces of it you need to help you feel confident in answering those questions. So the first part was focusing on rational numbers. So if you remember, a rational number is a number that can be written as a decimal, can be written as a fraction, and then we can turn them into decimals by dividing. The two types of decimals we talked about are terminating. Remember, those are the ones that end, so they stop after a couple decimal places, or repeating decimals. Those are the ones that repeat the same number or numbers over and over again. So if we get either of those two types of decimals, we know it was a rational number. So next part is how do you turn a rational number into a decimal? Well, think of something like 3/4 if we want to turn that into a decimal. The way to do it is by dividing. We divide the numerator, the top number, by the denominator. So we basically just do a short division problem. So let's see that in this first two. So we have 5/9. Remember, the numerator goes on the inside, 5 divided by 9. And we know when we do one of these problems that we're going to end up getting a decimal. That's the whole point, is to turn it into a decimal. So it's good just to go ahead and add that decimal point after 5, and you can kick in a couple of zeros. So that'll allow us to keep dividing if we need to. Then we go ahead and we divide. So we start with, how many times does 9 go into 5? Well, it goes in 0 times. So then instead of 5, I'm going to look at 50. How many times does 9 go into 50? Well, it goes in 5 times. 5 times 9 is 45. I subtract, and I get 5, and then I bring down my next digit, which is my 0. So I got 50 again. So how many times does 9 go into 50? Well, it goes in 5 times, which is 45. Subtract to get 5, bring down another 0. Hopefully you quickly realize this is just going to keep happening over and over again. I'm going to keep getting 50, I'm going to subtract 45, I'm going to get left with 5, and keep going on and on. That means it's a repeating decimal. So once we kind of realize it's going to repeat, we can stop, and then we just put that bar over the top to show us that those 5s are going to keep repeating. So we got 0.55 repeated, which is really the same thing as 0.5 repeated. We're just going to get 5s over and over again. So how about the next one? 5/8. So 5 divided by 8. And I just like to give myself at least 3 decimal places, because you never know how many we're going to need. 8 can go into 5 0 times. So instead of 5, we're going to look at 50. So 8 goes into 50 6 times. 6 times 8 is 48. Subtract, and I get a 2, and then I always bring down that next digit. And now we kind of repeat our steps. 8 goes into 20 2 times. 2 times 8 is 16. So we're trying to see how many times can my 8 go into that number without going over. How close can I get without going over? So 20 minus 16 is 4, and I bring down another 0. 8 goes into 45 times, which is exactly 40, so I'm left with 0. So when my dividing leaves me with 0 left over, and there's no more numbers I need to bring down. I could bring down some more zeros, but that's not going to really do anything for my answer. I know I'm done, and I got an answer of 0.625. That's a terminating decimal, just like our first one was a repeating decimal. So it says, next one says 5 out of 6 students got an 80% or higher on their math quiz. What is the decimal equivalent? Basically, that just means turn it into a decimal for the students who got an 80% or higher. Well, it told me 5 out of 6 students. Well, I can write that as a fraction. 5 out of 6. but it wants it as a decimal. So 5 divided by 6. 6 goes into 5 0 times. So instead of 5, I'm going to look at 50. 6 goes into 50 8 times, which is 48. Subtract, I get a 2, and I bring down my 0. 6 goes into 23 times, which is 18. Subtract, and I get a 2, and I bring down another 0. 6 goes into 23 times again, which is 18. Subtract. You'll notice that I'm going to keep getting that 20. Minus 18 is 2, turns into 20, minus 18. So that 3 is repeating. So I'm going to put a bar over just the 3 in my answer, and I got 0.83 repeated. It's just the 3 that's going to keep going, so I put the bar over just the 3. All right, next one. So now we're doing adding and subtracting. So what is an additive inverse? So we've talked about this a little bit here and there in class. A lot of times we'll call it something different. Sometimes we call it adding the opposite. But it's basically the idea of, if we have the problem 8 minus 5, the additive inverse is what number would I add instead of subtracting 5? Well, I could add a negative 5. So additive inverses are 5 and negative 5. What do you notice about those two numbers? Well, they are opposites. So the additive inverse is what would I add, what's kind of the opposite of the number that I'm subtracting. I was subtracting 5, so the additive inverse is what would I add instead? Well, I would add a negative 5. So 5 and negative 5 are additive inverses. All right, so the next one, adding integers. So here's our rules from our song. If they have the same signs, we're going to add them together and keep the signs. If they have different signs, we're going to subtract and take the sign of the bigger number. So for the first one, they have different signs, so I'm going to subtract. 19 minus 8 is 11. The 19 was bigger, so it's going to stay a positive. Negative 14 plus negative 25, they have different signs. Or sorry, they have the same signs, my bad. So I'm going to add them together. 25 plus 14 is 39. And we're going to keep the sign, so it's going to stay negative. 63 and negative 54, well, they have different signs, so I'm going to subtract them. Think of them as they're kind of battling against each other. And I get 9. I'm going to take the sign of the bigger number. 63 was bigger than negative 54, so it's going to stay positive. Last one, negative 8.25 plus 7.6. So I have a positive and a negative. That means I'm going to subtract them. For subtracting, I always put the larger number on top. 8 is bigger than 7. Remember, for your decimals, you need to line up those decimal points. So I'm going to add that extra 0 at the end of 7.6. I'm going to subtract, and I get 0.65. But I'm going to take the sign of the higher number, which one will have the bigger absolute value, the larger number. The 8 was bigger than the 7, so it's going to stay a negative. Okay? And that helps us a little bit with our question at the bottom. What's the absolute value of a number? It's how far the number is from 0. Think of it as how big of a number it is. So basically, it's not worried about its sign, it's just worried about the size of the number. How far is it away from 0? All right, now we're on to subtracting. And here's our key. We want to rewrite it as adding the opposite. So anytime we see subtraction, we're going to change it to adding, but the next number has to become its opposite. So here I have negative 9 minus 15. Well, that's going to become negative 9 plus negative 15. Subtraction became addition, but the next number became its opposite. Now I just add. Negative 9 plus negative 15. Same signs, add and keep the sign. So negative 24. Here, 47 minus negative 23. Well, that's going to be 47 plus positive 23, because I'm going to change it to adding, but the next number becomes its opposite. Same signs, add them together, and we get 70. All right, next one, negative 6 minus 13 plus 20. So I see subtraction, so I make it adding the opposite. So negative 6 plus negative 13. But the plus 20 was just addition, so I don't need to change that. I want to leave it as addition. Negative 6 plus negative 13 is negative 19. Negative 19 plus 20, those have different signs. We're going to subtract and take the sign of the bigger number, which was positive, so I'm going to get an answer of 1. All right, last two. Now I've got my decimals. So 17.49 minus negative 5.32. Remember, when I see subtraction, I'm going to make it into addition, but the next number becomes its opposite. So instead of negative 5.32, it's positive. So same signs, we're going to add them together. Remember to line up those decimal points. That decimal just slides down. And I get 22.81. They were the same sign, so we're going to keep the sign. So it's going to stay positive 22.81. Last one on this side, 7.50 minus 10.78. I see subtraction, so I'm going to make it adding the opposite. So it's really 7.50 plus negative 10.78. They have different signs, so I'm going to subtract. But 10 is bigger than 7, so the 10 is going to go on top. The 7 goes on the bottom. I'm going to subtract, and I get 3.28. But they had different signs, so I got to take the sign of the higher number. The 10 was bigger than the 7, so the negatives are going to win. Negative 3.28. All right, so there's your answers for the front side. Now let's take a look at the back side real quick, our word problems. So these are ones where it's good to write a picture or sketch something out to really help you focus on what's happening before we try to do the math problem. So it says Mike and Harvey are having a diving contest. Mike dove to 25 feet below the surface of the water, and Harvey dove to 11 feet below the surface. So since we're dealing with below the surface, we know those are both going to be negatives. So I'm going to draw one of my fantastic pictures. Mike is down here at negative 25. Harvey is down here at negative 11. We want to know how far apart are those two numbers. Well, that means we're finding the difference. We're subtracting them from each other. So I'm going to do negative 11, Harvey's number, minus Mike's number, which is negative 25. And here's the key. Yes, we're subtracting, but we're subtracting a negative number. So think about what we just did on the front side. When you're subtracting a negative, we change it to adding the opposite, which is really a positive 25. Negative 11 plus positive 25. They have different signs, so we subtract. 25 minus 11 is 14. So they are 14 feet away from each other. Number 10, Evelyn and Emma were at the swimming pool. Evelyn was 12 feet above the water standing on the diving board. Emma was swimming 7 feet below the water's surface. So Evelyn was 12 feet above. Emma was 7 feet below. So one's a positive, one's a negative. So here's my water at the pool. Here is my awesome diving board. Okay. So Evelyn is 12 feet up. Emma is 7 feet down, so negative 7. And 0 is kind of in the middle. So we want to go all the way from negative 7 up to positive 12. Well, we want to find the distance between those. That means the difference. How far apart are they? So we're going to subtract. So 12 minus negative 7. Okay, we got to keep that sign. Subtracting a negative is the same thing as adding a positive. So it's 12 plus 7, which is 19 feet apart. All right, last one. I'm almost done. At 8 a.m., the temperature was negative 6 degrees. Well, here's negative 6 right there. The temperature rose 18 degrees. So that means it went up by 18. So we want to count up on our number line 18 spots. And we would end up at positive 12. We went up 18. But then it dropped 9 degrees. So it went down 9 degrees from 12. So we're going to count down by 9, and we ended up at 3 degrees. So what was the final temperature at the end of the evening? Positive 3 degrees. So by using my number line, I can kind of map out how it moved up and down until I can get to that final answer.